Welcome everyone to this new tutorial. Even though this will be a strict Android tutorial, we will be joining it with a previous work, the 4 switches, the first chapter of the switches series. I'm going to show you how to set up a basic and simple configuration to have a set of buttons mirroring the switches we made, and how to send and receive UDP signals to toggle the on-off states. So let's get started. As you can see in the picture, for this we will need an Android phone or tablet to install or use Android Studio, in which we will be coding and deploying our application, and at least a Node MCU or ESP8266 or similar. You don't need to build the entire 4 switches or a complete and finished relay implementation. You can play around with just a simple board by debugging the Arduino IDE console, or if you want to have more fun, improvise simple connections with a few relays, the type you like the most, or maybe a simple set of LEDs. But if you want to become an expert, go through the switches tutorial. As a matter of fact, the diagram you see in the screen demonstrates what this project is all about. As you can see, you will be able to control remote electric power sockets by sending and receiving UDP signals through your local network, with an interface representing each socket that will show the state of each socket every time a switch status is toggled. In each signal sent, we will receive the status of all switches, so the system will be able to update the status constantly. If a switch has been changed by another device, this interface will reflect that change. You can clone our repository or check out this branch if you have previously worked with our tutorials. As you can see, we slightly introduced new features in this new branch. We used to have only the main activity class in which we coded all our needed functionalities just for simplicity reasons. Now that we have more knowledge, we will be splitting the code into different units to make it more clean. We will introduce concepts like dependency injection and polymorphism. Dependency injection is a design pattern where the dependency of a software component are injected from the outside rather than created within the component. Polymorphism is a programming concept that allows objects of different types to be treated as objects of a common type. In other words, it enables a single interface to represent various types, and a single operation can work on different types of objects. So that being explained, let's see the code. Please take a look at this for an overall view for the complete structure of the Android application. In this tutorial, we will be explaining the components related exclusively to the Java code. We will have 3 main components: the main activity.java that contains the basic configuration, and the well-known onCreate method that contains the construction of the object required for controlling the UDP communication and the buttons toggling. UDP transceiver.java is in charge of the UDP emitting and receiving. Button handler.java that will represent each button or switch. So basically, when the application starts, the onCreate method will loop through a fixed list of details describing the buttons we will be dealing with. This in future improvements could be managed by a configuration phase of the application and stored in an internal database or a persistent resource. Then we create an object from the UDP transceiver.java to handle all UDP communication from now on. This will be used to check the first states of the buttons, and we will be injecting it to all the buttons we will be creating. Notice that with this action we will be able to split the code and reuse features created by passing it to new components. Then we create each button and pass the information required to handle their states like ID and name. And of course, the UDP transceiver in the list itself of all buttons. This last one gives the capability for each button to check and update the status of all. And finally, we add the created button to the map of key value called buttons. Finally, the toggle of each button in the view will trigger this function. the onToggleClick function or method, which is triggered by the button defined in activity main.xml. Basically, and thanks to this pattern we have created, we simply get the ID of the button toggle, retrieve the button identified by that ID, and execute the function toggle. ButtonHandler.java will have a main method toggle that will be sending the toggle signal defined by the actual status of the button and receiving the update status, handling possible errors, changing the level of the button on/off, checking the update status for the rest and updating them. This is in case another device changes the status of the switch, returning the response with the information about what button has changed to be printed in the main. Now take notice that this is not exactly a polymorphism structure, since it's the same class for same behavior. What is changing is the information inside each button that makes it act differently. The idea with the polymorphism structure is to define an interface and complete different classes implementing that interface. But for this case, I think it's fair enough. We will deal with more complex scenarios in the future. And last but not least, UDP-transceiver.Shella. This one is simple. Can send a UDP package and wait at most 5 seconds to receive the update status. Regarding what we just built here, I feel there is still space to improve. Regarding, for example, the activity main.xml, the buttons are hard-coded. In our example, we use 4 switches. The idea will be to make the buttons dynamically. In this way, you will be able to configure all switches you want in your home or office, so you can control as many switches as you want. On the other hand, there is a future tutorial in this series to control the switches with your voice. And why not add this feature to this same application? We will see. See you in the next one. Have a good one.